Okay, so we did 1 through 18. Question number 19 says this equation, so this function is the graph shown in B. Use the graph to factor the polynomial. Okay, so I am looking at the graph in B, and I'm trying to write the equation for that graph. So you can go ahead and just put this on the bottom of your homework page. When I look at this graph, we know, first of all, it has an even degree, right? And in fact, we saw the equation, it even gave us in question 19, it's an x to the 4th. It opens up, so the coefficient's up. So we know all of that. The thing that we kind of touched on yesterday, but we haven't really done a lot with, is the x-intercepts. X-intercepts are where a graph crosses the x-axis. They're also known as zeros. And the very last thing we wrote down, but we didn't go into a lot of detail, is what causes a graph to bounce at a zero? An even multiplicity. Okay, so if my graph hits the x-axis at -5, that means when I plug -5 into my equation, it equals 0. So if I'm trying to write that as a factor, that's with an x, would I have to put x minus 5 or x plus 5? Plus, right? Because when you plug in a -5, -5 plus 5 is 0. So my factored form, I'm going to have one parenthesis that says x plus 5. But when I look at that graph, it bounced there. That means the multiplicity is even, the power is even. So I would need a square on that parenthesis. So you guys should all be writing this down on your paper. Question number 19. Okay, do you guys all see why I have the x plus 5? -5 is an x-intercept. So when I put -5 into my equation, it has to equal 0. It got a square because my graph bounced. What's the next place it hits the x-axis? 0. So how would I write that? 0 has to make it equal 0, right? So I could say x plus 0, x minus 0, but that's the same thing as just x, isn't it? So I have to have an x. Now you can put it anywhere. Typically if we have just a plain x, it's in front, but it doesn't really matter. Does that one get a square? No, because it doesn't bounce. Where else do we hit the x-axis? 3. So what would my factor have to look like? Would it be x plus 3 or x minus 3? Minus 3. So that when I plug in 3, it equals 0. That one, did it bounce? No, so it doesn't get a square. Quick check. If I look at this, x plus 5 squared, x minus 3, would that be a power of 4 if I multiplied it all out? Yes. So that is my equation. I wrote the factored form by looking at the graph. Now, later on in this chapter, we're going to do a lot more with getting this factored form. This is just kind of our first try at it, looking at the graph and recognizing those things. Are there questions on any of those?
Why'd you put the x in the front again?
It doesn't really matter. Typically, if it's a plain x, we usually write it in front, but if you put it at the end, it's fine too. Multiplication can happen in any order. Other questions? So question 20 says, here's another equation. It's the graph in D. So we're going to do the same thing for graph D. We're going to write the equation. Okay, it's an x to the 5th, so we have the correct in behavior, but notice it's up, down. What causes that in behavior to flip? A negative. When we looked at the equation on number 20, did it have a negative in front? Yes. So I need that somewhere in my equation. I'm just going to put it out in front. So I know it's a negative because my graph is flipped. Okay, where's the first place it hits the x-axis? -6. So what would I write in my factored form? X plus 6. Did it bounce or go through? It went through, so it doesn't need a square. The next place it hits, kind of hard to time.
-1.
So at -1, what would I put? X plus 1. And that one bounced. So that one gets a square. Okay, where else does it hit the x-axis? So that would be x minus 3. And that one, does it get a square? No, because it didn't bounce. Where else does it hit the x-axis? So that would give me x minus 5. Does it need a square? No. Quick check, does this give me an x to the 5th? 1, 2, 3, 4, 5. So that's an x to the 5th. The negative, which I needed because of my end behavior. So that's my final answer. So these last two questions were really just using what we knew about the graph so far. Hello. Okay, so there's really two things that we are going to talk about today. We're starting section 4.2. We will finish it tomorrow. So the first piece is a helpful feature when we get to the next section in this chapter. It will be a time saver for you, so we do want to make note of that. And it's what's called the intermediate value theorem. So what it tells us is if we have a polynomial, first I'm going to draw a picture and then I'll write it out in words. We talked a little bit about polynomials yesterday, and I told you that their graph is always a smooth, continuous curve, right? No breaks in that graph. It's all nice and neat. So something like this might be a polynomial. Okay, what the intermediate value theorem says is if you can find a place where the graph has a positive y value, so for whatever this x is, it has a positive y value, and then if I can find another place where the x gives me a negative y value. Because it's continuous, the only way to go between a positive and a negative is to cross through 0. So when we are talking about these and we're trying to decide where are my x-intercepts, if I know, for instance, when my x is 1, I get a negative value, and when my x is 3, I get a positive value, that means there is some place between 1 and 3 where my graph will hit the x-axis. So if we write that in words, let's say in a polynomial, if f of a and f of b have different signs, there must be an x-intercept between a and b. So there is some number between them that I could plug in and make that entire graph equal 0. It will hit the x-axis. So here is a polynomial. I want to show that it has a 0 between 2 and 3. so what we're going to do is we are going to plug a 2 into this equation, and we are going to plug a 3 in. So when x is 2, what do we get out? Use a calculator if you need to. -1, I believe. Double check me. Okay. Then we plug a 3 in. If you put a 3 in for all the x's. Okay, what that means, the picture isn't required, but just to explain it to you. 2, -1 is a point on my graph. 3, 7 is a point on my graph. We know it's a polynomial, so we know the graph is continuous. So the only way to get from a -1 to a +7 is by crossing through 0. So there is a sign change. So a 0 or an x-intercept exists between 2 and 3. So there is some x value between 2 and 3 where the y is 0. Let's talk about how to use your graph to find that. So I did put some on the homework, actually using the graph to find it. I wouldn't on the test because we don't have the graphing calculators on the test, but I wanted to show you how to use it. So this is our polynomial. We are going to graph it. So you're going to go to your y equals, and you're going to type that in. X to the third minus 2x squared minus x plus 1. All right, so if we look at this, does it look like between 2 and 3 we cross the x-axis? Yeah. We can actually find that point exactly if you do second trace. Which of these things do you think I want? A 0, number 2. So it's going to prompt you. It's going to ask you some questions. Polynomials go on forever. So it can't search the entire graph for you. You have to say start here and stop here. So the first thing it says is left bound. All right, we are looking for this particular x-intercept here. So your left bound just has to be somewhere to the left of that. Okay, so somewhere before that point. So then I hit enter. Right bound, I just have to go past my x-intercept. So you have to tell your calculator you're going to stop looking when you get to here. So you do a left bound enter, then you go past your point, right bound enter. Yep. Just hit enter, and now it's going to say right. So go past. And then it's going to say yes. You don't really need to worry about that, just hit enter one more time. And so then it tells me my 0 is 2.2469796, okay, or approximately 2.25 if I were rounding it. Okay, so you can use that calculator to find the actual 0. So on the Math Excel, there are a couple questions that will say use a graphing calculator to approximate it. That's what you need to do. So raise your hand if you did not get that to work. questions on that? Here's just a question for you. If you have 2 points that are the same sign, does it mean there's not a 0 between them? For instance, if I put in 2 and I got 1, and I put in 4 and I got 2, does that mean it can't cross the axis between them? No, it could cross multiple times. So if it's the same sign, the intermediate value theorem doesn't tell us anything. If it's different signs, that's when we know for sure that there's a 0. All right, are there questions about this? Second thing I want to talk about is to set us up for some of the stuff we're doing tomorrow. We need to review synthetic division. You guys remember doing that at all in the past? Perhaps? So it takes the place of long division as long as we are dividing by something linear. So we can use this to divide polynomials. All right, so I want to take 5x cubed minus 6x squared minus 28x plus 8 and divide it by x plus 2. So with synthetic division, it's a shorthand for division where we can basically ignore the variables for a minute. So look at what we're dividing by, x plus 2. What makes x plus 2 equal 0? So negative 2, right? That's the number that's going to go out here, so I'm going to put in negative 2. And then I'm going to put my coefficients. We have a 5, negative 6, negative 28, and positive 8. With synthetic, you do have to make sure if you have a missing power of x, because I'm not writing my variables down, you have to include a 0. So for instance, if it went from 5x cubed to negative 28x, you'd have to put a 0 for your x squared. And then we're going to skip a line, leave yourself some workspace. The first number just comes straight down, so we carry the 5 down. Then it's just a series of multiply and add. So you do 5 times the number in the box. So 5 times negative 2, negative 10. And on this line we're just adding. So negative 6 plus negative 10, negative 16. Multiply. Negative 16 times negative 2 and add. Negative 28 plus 32. Multiply. 4 times negative 2 and add. 8 plus negative 8 is 0. Once you get to the end, this last number represents the remainder. This is my constant. And then it's increasing powers of x. So it would be x and x squared. So my answer is 5x squared minus 16x plus 4. Since my remainder is 0, we just leave that off. Any questions on that? Do you remember doing that before?
So if the remainder was like 1, would your 4 turn into your x?
You would write it as 1 over the thing you were dividing by, x plus 2. So your remainder is always going to be written as a fraction over what you were dividing by.
Thank you.
You're welcome. All right, so let's try some more of these. With the synthetic division, when something divides evenly, that means it is a factor. So x plus 2 divided and didn't have a remainder, so it is a factor. So this is something useful that we want to write down, the factor theorem. If x minus k is a factor, then f of k is equal to 0. I'll let you write that down. So there's two ways of thinking about this. If something is a factor, then what it means is in the long division, the remainder is 0. So like the problem we just did, we divided, we got a remainder of 0, so that means it's a factor. The factor theorem also tells us a shortcut. So on the problem we just had, it was 5x cubed and we were dividing by x plus 2, right? So we did the synthetic, we got a remainder of 0. What happens if you do f of negative 2? So grab your calculator if you need to, plug negative 2 in for all of your x's, and tell me what you get out. You get 0. So notice 0 was the remainder. When you plug the number in for x, you get the remainder out. So if I don't care about the entire answer to the division problem, if I just want to know if something is a factor or a 0, you could just plug in the number. If we get 0, it is, otherwise it's not. All right, so we're just going to use this and do a few problems. Before we do a problem, I do want you just to jot down a couple things. I want you to make sure you know the difference between a factor and a 0. So the factor has x. 0 is just a number. So my factor would be x plus 2. The 0 is what makes x plus 2 equal 0, which is negative 2. If my factor is x minus 7, what's the 0? Positive 7. If my factor is x plus 10, what's my 0? Negative 10. So you have to be careful. We're going to hear those both words a lot for the next month or so. So factors are with the x. A 0 is just the number. Okay, so I want to decide if x minus 1 is a factor of this. So there's two options. We can do synthetic division or we can do the remainder theorem. And I'll do A and B two different ways just to show that. One option, if it's a factor, what does my remainder have to be? 0. So if I wanted to do the remainder theorem, what number would I have to plug in for my x? 1, because that's what makes x minus 1 equal 0. So you could put that in for all of your x's. And you get 0. So is it a factor? Yes. The other option is to do what? Divide them. So if I wanted to do B differently, you could certainly still just plug in. What would you plug in this time? -2. Or we can do synthetic division, whichever one you prefer. So remember, it's synthetic division. You put what makes x plus 2 0, so that's a -2. You put your coefficients. If you jumped powers of x, if you have any missing powers, you do have to make sure you put in zeros there. And so then, to do our synthetic, the first number just comes straight down, and then we multiply and add. 2 times -2 is -4, -1 plus -4 is -5. -5 times -2 is 10, 2 plus 10 is 12. 12 times -2 is -24. -3 plus -24 is -27. So is this one a factor? No. How do we know automatically? It's not 0. What if I'd asked you to write the quotient? What would this be if I wanted to write it out? This is my remainder, my constant, x and x squared. So we don't have to here, but if I'd asked for the answer, 2x squared minus 5x plus 12. And since we have a remainder, you could say plus -27 over x plus 2, or just minus 27 over x plus 2. Okay, so with those synthetic divisions, if you don't get a remainder of 0, you just write that remainder as a fraction. Last problem of the day. So I just want to do the same thing, but this time I want to know, is the number a 0? So how would I decide if 2 was a 0 of the polynomial? Well, actually, if I already give you the number itself, not the factor, you just plug in that number. So you could just plug in 2. Or you could do synthetic division and divide by 2. And we get 0. So is that one a 0? Yes. B, what would I plug in? -2. If I give you the number itself, you plug in that number. If I give you with the x, it's always the opposite. I think it's -19. Is that what you guys got? So is that one 0? No. We are going to continue this section tomorrow, but there is a Math Excel sign open. This Math Excel has some questions from yesterday, so the first half of it is just in behavior type questions, and then the second half has some of the division questions.